Hello to everyone, and welcome to our February virtual meetup for mechanical engineers. And today's topic is Autodesk Factory Design Solutions. My name is Anton Fedoseev. I'm the content strategist within Customer Success Organization at Autodesk, and I'm your host today. Today we have two great guests, Peter de Strijker, from Europe, from Belgium, who's our senior application engineer specializing on factory design solutions, and Steve Pora, designated support specialist here in the States. They will introduce themselves in a second. But before we jump to actual presentation, let's cover the basics of like what's going on today. So first of all, all the lines are currently muted because we need to reduce the background noise, and the session is recorded. If you have a question, just type your question in the related panel, and the webinar will be recorded in a couple of days from now, maybe on Monday, on Customer Success Hub, and also you will get it in your inbox. So shortly, quick reminder about virtual meetups. It's recurring session, recurring webinar that happens every second Thursday of each month. So you can see the cadence like January 9th, February 13th, etc. So it happens every second Thursday, and we are covering rotation of topics, and we have guest speakers from Autodesk and from product management team. It's a part of a larger series because we have also generative design webinars in the same format. It's the last Thursday of each month, as well as it's a part of like even larger program where we have virtual meetups for key professions within our industry domains, and the same format. Meet the experts, open microphone when we invite customers, and updates from product teams. So stay tuned. I will drop the link in the chat window. And the first presentation will be from Peter. And Peter is based in Europe, and he's been one of our main experts in the factory for a while. So Peter, can you say a couple of words like when you saw or when you started using any kind of factory design solution, and like what was your first experience before we jump into your presentation about digital twin?
Well, first of all, thanks for the introduction and having me in this meetup webinar. I work now for over 10 years for Autodesk, and I think halfway my career, they showed me the early beginning of the factory idea and the factory layout tools idea, and I immediately jumped on that, and I wanted to be expert in this because I just like the technology they developed at the time, and it's still a great product. And for so many customers, no matter where in the world, in Europe, Asia, or Americas, it's a tool that's in the collection, in the offering, and only a few companies really touch this because they don't really know what to do with it and how it works. So that's a real nice opportunity today to show where this tool fits in the entire big picture of a digital twin of a factory.
Yeah, that's a great starting point. So the format of today's virtual meetup is that we'll have a presentation from Peter that covers factory a little bit, but it's more in like larger context of where it could go if you keep investing in factory design solutions. And then we'll have a presentation from Steve, who will cover more about like implementing and making your first steps from like rolling out the solution in your organization. But the stage is yours, so let me give the sharing permission to you, Peter, so you can share your screen in a second.
That's what I'm doing right now.
Yep.
It's visible?
Yep, I can see yours. Yep.
All right, so let's kick off. And so the introduction is done. Again, today's focus is on factory design utilities, which is available for everyone that has a collection or is an EBA customer. What I wanted to do is not going into detail in the picks and clicks and the use of the factory, but more position it in a bigger picture, as Anton already said, in a picture of a digital twin of a factory. And the reason for that is that we see a lot of changes and driving the changes in a factory, and see what we can do with this tool to make this more, let's say, relevant for this topic. So first of all, what is driving change in a production site? First of all, the new product introduction can be a good trigger for changing production lines. And today's life cycle of a product is shorter, is shorter than, let's say, 5 years ago. So we need to reinvent and optimize the production lines based on a faster pace to make new product introduction quicker to the market. There is also the customer side. Customer, let's say, ask for more personalized goods, which gives the production a more complex environment, and or people need to have more efficient products or different technologies. Like, for example, building an electrical vehicle is completely different than the normal cars. So this demands production line changes. It can also be cost-cutting initiatives. You need to have a cheaper product on the market with a better quality. So these are all things that can drive changes in a factory. I know not everyone has all these, let's say, the changing drivers, but some of them will be very familiar to most of you. So to make these changes to your production area, or to make the changes based on what the market is asking you, in this world of manufacturing, a company needs to be agile. And the ability to adapt quickly for change is critical for long-term business growth. So if you can make a well-decided change on a virtual model before you go in the real physical world, this can help you to make very critical and quickly changes for a long-term development. This information we got from a Accelerator survey we sent out to factory owners, because they recognize that there are triggers that force them to make changes. But when it comes to factory changes, the common outcomes are mainly missed due dates and cost overruns. So the 3 first topics is really project-based. The projects that were initially initiated were too expensive, were out of budget, and especially missed due dates can be very critical, especially when you go in serial productions like automotive world. Every day that you miss a production day, it costs a lot of money. To give you an example, if you go overrun the project in time, that can cost over $100,000 a day in the automotive example we're showing here. Incorrect measurements and field checkings when the equipment has been installed, is installation, that can cause project delay as well. So you have the incident cost plus the risk that you go over that project date. If you have field change orders, meaning that the equipment doesn't fit with the building, and you have interference when you're in the building process, that can cost a lot of money, because the building won't change. You need to make other equipment that avoids that interference collision. So these are the risks if you don't simulate and prepare these changes properly up front. So let's look at the challenges, what we have on the other side. So once we recognize this need for change and the risk we have, we are aware that this change opens an opportunity to improve the line. But this improvement also involves possible risks. So if, for example, if there is a poor integration between the process planning, the layout, but also the facility, you can go out of the budget and out of time, and that's something we want to avoid. And the main reasons why projects go out of time and out of budget is, first of all, a poor collaboration, because building a production line is not only the mechanical engineer of the machine equipment provider that has to deal with it. It's the entire picture with the building, with the logistics, and so on and so forth. So collaboration and communication is key in this process. Also, we see design efficiencies coming up. If you can't exchange data from the one silo, which can be the architect or the facility designer, and on the other hand, the machine equipment designer, if you can't exchange the data, you will end up with probably collisions on site, which is not really the thing what you want to have. And the major thing we find in a digital twin is that you can test designs before they are built. So testing the virtual outcome is key, is the best starting point to avoid these due overrun dates and the cost overrun issues. So with Autodesk, we can cover these 3 steps in let's say a facility build and modification. So the first one is plan and design. The second one is construct and commission. And the third one is, once the facility or the production line is running, the operational efficiency of the factory, which means, can we feed back information from the operational model into the virtual model to make a better version 2 or next generation of this line. So this is the entire scope and the entire picture what I want to show you today, with the main focus on the factory design utility to show you how to build up this kind of virtual twins. So let's start with the plan and design. When it comes to efficiency planning and design of a facility, it helps if your team can collaborate on an integrated factory model. So if everyone can contribute to that model from inside, but also let's say suppliers outside your company, if they can contribute to that model, it gives you a more consistent environment where the risk of errors and mistakes is smaller. So, but how to create this plan? So how can improve design efficiency? Well, we need to have a virtual twin, and based on virtual models in a 3D environment, we can generate walkthroughs where we can visually check collisions, where we can experience the facility before it's built. We can calculate collisions, and but not least, we can create cool marketing stuff that we can use as in the bidding phase, even in the pre-sales phase, to convince the customer what he's going to get at the end. So let's start with the virtual walkthrough. So beginning at all, this is the factory design utilities. It's a product or an add-in based on AutoCAD, Inventor, Vault, and Navisworks mainly. And it allows you to build up the layout as you're used to do it before, in this case, AutoCAD environment. But instead of using the regular blocks, we're taking the machines and equipment out of a factory asset library. This is a common library throughout the entire design process, which consists out of 2D blocks and 3D models linked to each other, plus extra tools like, for example, the chain assets, who can convert a polyline into a chain of equipment, what you saw with the conveyor lines out there. So you can still create the layouts as you did before, but in a new fashion way based on the library that gives you the benefits. If now we have made this library or this layout on 2D, we can open this 2D layout in Inventor, which automatically will populate all the 3D objects that are related to the 2D blocks below. So this is a one-click operation where you can experience the 3D environment of that same layout. As you can see in the window, also Vault is involved here, because this project can be managed by Vault. Not only the project, but also the library can be managed by Vault. So this is a 100% Vault certified workflow. So you can still build up the assets now from the same library as we did in AutoCAD, because it's a common library, as I told you. But the advantage we have also here is that we can easily replace assets we can put in new assets, and automatically it will connect to the neighbor asset and carry over parameters. So that means that the width of this conveyor belt now is transferred to the new one. Plus also we can insert assets and change the parametric dimensions of it. So it connects again, it changed size, and now we can change or modify the length based on what we have measured in as an open space. Because this is an Inventor integrated application, we can use the Inventor tools and the Inventor functionality as well. For example, this asset is driven by a logic script where we can change the place of the controller. So we use a logic now to just change the location so of the asset, which creates a new asset. So the equipment list will have the right documentation saying that this controller needs to be in this place. So you see, so we can build up very quickly, very easily the layout based on connection points as well. You see, it snaps on these connectors, which automatically position and orientates the equipment in the right way as where it's built for. So you see how quickly and fast we can create layouts based on this factory asset library, which is partly filled with equipment that comes out of the box, but you also can add your own customized library assets in there as well. So the last but not least, in this case, as the robots have a certain operational area, so we need to check if there can be collision later on. So what we did is the operational sphere around the robot as a check surface to see if it goes all well. So this is the foundation. This is the start, the basis of creating the digital twin and having the 3D model as a walkthrough element. So as I told you before, this factory line equipment is not standing on its own in the air. It's in a building mainly. So it's important, it's key that we can integrate and reuse architectural data. Can be the building, can be the ducting work, can be the steel work, that we can integrate this information inside my engineering environment to see if my mechanical engineering fits with the building. And this is where the most of the companies goes wrong, that they put it together at the latest point and then have to make some modifications because they didn't see collisions, they didn't see, let's say, mistakes in the digital model. So this is where Autodesk plays an important key role, because we cover these both disciplines, both architectural and mechanical engineering. So this is a sweet spot for Autodesk because we can easily create this kind of mockups. And based on this model, if we have this model now available, we can have the walkthrough functionality that allows us to walk and navigate inside this facility, check and calculate collisions, but also create very nice imagery based on this model in a few clicks. So you can see we have a cloud rendering service that allows you to create really thrilling images, 3D panoramic views in a few clicks. And it takes, let's say, about 10 minutes to create one. It's a cloud-based, so you can continue working. You will be notified when it's ready. This is what you get at the end. And not only a static in the web browser visual, but take your cell phone if you want. I'm going to show you a QR code, which is going to pop up in a minute in the screen. Well, this QR code, if you scan this QR code, you can have the same cool visuals on your mobile, your cell phone even. So I'm going to keep this a little bit on the screen. So if you want to check it, I give you, let's say, 10 seconds to scan this, and you can experience the result on your cell phone. So this is what you get in, let's say, a couple of hours. And it's the same work as what we see people doing on a 2D AutoCAD drawing. It's starting from creating 2D blocks, 2D AutoCAD block layouts. So I hope everyone had a chance to scan the QR code and experience now the 3D model on its cell phone. This is what you get very easily out of the technology. So the virtual the walkthroughs that we can check off. The next one is how to capture the as-built situation. So not every facility has the models or the drawings behind it already. So what if we have to modify or change an existing facility? Well, then laser scanning is one of the important technologies to do this, to capture this. And at Autodesk, we have tools to, once the scans are registered, to clean out, to edit, and to change, let's say, the content of the scan, because we need this information sometimes as a reference in my design environment. Also very cool, let's say, definition of this, what I heard from a customer is he said, with point cloud scanning, we bring the facility to the engineer. And what we did before is we brought the engineer to the facility, which is a very good statement, a very cool statement, and it's so true. So you can measure inside this point cloud. So if you forgot something to measure, you can still go in here and take the measurements out of the point cloud. Next, so before really creating a layout, it's key to test a process, to test the design. And in this case, we can analyze the production process before even start creating a design. So with this process analysis tool, it's easy to set up a process as a flowchart, run it, and then if you have, for example, takt times that can be set as a standard, then you can compare these results in charts to see if your process times meets your requirements, or for example, if you have bottlenecks in your line. Is the machine waiting for 80% because the machine or the process before can't deliver let's say the goods as fast? So this is something that is key for having this as a tool before you even start drawing a layout. The next step, for example, can be the digital simulation of the product and the material flow. So the first one was the process flow. In this example, we have the tools, in AutoCAD in this case, to show and to calculate the product flow based on the physical layout of the model. That means this AutoCAD layout has the right position of the tools, the right distances between the processes. So by moving a line, we can calculate the impact on the process time. So you will see that the time of 40 minutes will go up or down depending on where we position that the line, see, and also the distance. So this is something you can use as a decision tool, where to put the line or where to put the new equipment in here. So the plan and design, there is where the factory design utilities plays a very important role, and it's a key product to make the entire workflow possible. Now we're going to have to look to the challenges during construction and commissioning. Communication here is a very important element in this commissioning phase. So if your teams can't share data and can't work together, it's almost inevitable that they will have collisions and cost overruns. That's something for sure. So if we have an integrated model, as we have here, we can communicate with different stakeholders sitting outside the company, for example, by using the share views to notify them there is a problem in the design, and the problem is not under my control because I'm the equipment manufacturer, and I can see that, for example, the architect has built an HVAC system that can collide with the working area of the robots. So I can ask him to make this modification and to move the, let's say, HVAC cooling nozzle or spray plus the lightning to move it a little bit away from that area. So this is something, if you can avoid these errors in a virtual design environment, this saves money, because if you have to do it on the floor, on the shop floor, that gives bigger problems because you don't have the equipment, you don't have the right piping elements and so on. So this can be challenging. So this is the communication now between the engineer and the architect. So he can go in the model, go back in the model now and make this check in this virtual walkthrough twin, let's say. And he can see it. You really see the collision over there. It's right. But you also can calculate the collisions if it's not so obvious to see the collision. If it's a small collision, you can really calculate if bodies touch each other and run into each other. So, no. And based on this information, the design engineer can now start making the modification in his native application where this ducting has been built. He can now start making the modifications by moving the objects to the new position, see? Out of this working range of area of the robots. It has been moved now, not yet, but it's going to be moved. Done. And if you save this and sync this in the right way, communicate in the right way, then the virtual model will be updated and you can recheck if the collision is gone. So another very important topic is the project timing. So you can have a theoretical timing when and how the project need to be built. In our tools, Autodesk tools, you can easily set this up as a kind of virtual animation to see when an equipment needs to be on the floor, and what's the sequence, what's important for sequence, because sometimes some objects can't get through anymore because the machine is already sitting there. So let's say the order that machines coming in and will be placed is very important to simulate. So we can do the theoretical simulation of the project, and we can overlay an actual one if you want. So we can see where we are losing time or going to be late in the project already. So that's something that's part of this workflow based on the equipment and the elements we've put together with the factory design utilities. So we have discussed now this installation and sequencing in Navisworks, which is very important to predict, let's say, the timings and so on. And it's also important to have a seamless exchange between the factory equipment and the BIM model. That's something that's so important to have. So with this, we can communicate and create deliverables for the wider stakeholders in the project. So not only the architects and the engineers for the equipment, but everyone in the project, like project managers, no matter what, in a cloud-based platform where we can upload deliverables, the latest versions and versioning of the files, to have always the latest and greatest documentation and information available on the construction site. See? So all these changes I've made is now public for the project manager on site, for example. And based on that, he can create also from this environment, he can initiate change orders when he detects an error or a mistake on the shop floor or in the construction site, for example. Then he can initiate a change order from in this environment. So to make the change back to the engineering and so on and so forth. So the next step is the operate step, and it's not the least important because information coming from the operate status can create better next versions of the factory of the line and so on. So this can be twofold. You know, it's not only the operational information or the feedback from the operational information, but can also meaning, for example, the management of the equipment. What's the life cycle of an equipment? What's the, let's say, the maintenance cycle of equipment? So all these things can be very important in managing and having continuous production lines. So in this case, I want to show you an example where the digital twin has been used as a mock-up to put the sensor data on top of it. So you see this symbols are all sensors in the machine. It's a kind of a virtual dashboard where you can see the operational data. This is now made visible, but we also can collect this data and feed it back in, let's say, the process analysis tool to compare the real world data with what we thought it should be. And based on this information, we can do real world simulations and to make the next generation better based on this information. So this is all based on web programming, where the digital model is key to position all the sensor locations. So to summarize this big picture, if we go to the phases of a factory lifecycle, we have first the plan, the rough layout, and the process concept, which was the process analysis tool we have. The design is key, and where factory design utilities plays a very important role. The validate is before going into construction, try to eliminate all the biggest errors and the clashes, take it out, and share it with the people on the construction floor. Building is sharing data, communicating, having the latest and the greatest information on the shop floor, and at the end, operational is connected assets or assets give feedback to the control system where we can benefit of the historical data to make the next one much better. And all this is all connected with data management or cloud services. So the good news is that all the technology shown here today is available throughout the collections, except of Revit. All the tools are available in the product design and manufacturing collections. For the EBA customers, all these tools are available through TokenFlex consumption. So this is now available. This is not a future story. This is a story you can implement today, and where factory design utilities plays a very important key role. So if you want to review this information, we have a landing page from Autodesk, which called Digital Factory. If you go to the web page, you can go to the entire story. It's well documented, it's detailed, explained, and you can have more information even on there. So if this triggers you, this is the place to go. With this, I want to end this presentation, and I want to thank you for listening and being here today. Thank you.
Yeah, and it's as a quick reminder, you can ask questions at any time. In fact, this is like great chance to ask questions live, and since it's a meetup, more or less formal space for all of us to interact. So feel free to type any questions that you have, and we'll be able to address them live. Peter, thank you so much for great and very inspirational presentation. Of course, it's a journey, right? What you showed, you have to start somewhere, and Steve will cover where to start or how to continue. I don't think that all of you on the call are like in the beginning of the process. But before we jump into this kind of starting thing, Peter, like what other applications do you like see for factory? Because obviously you personally like used it for like almost like shipbuilding and things like that. So what other applications are common for, you know, this factory suite of solutions?
That's a very good question, Anton, because I had someone saying lately, don't let the name factory stand in the way. In general, this can be considered as a layout tool. So no matter what has to be layouted, if you have the bespoke and appropriate library content available for that, you can lay out whatever you want. So I've seen this being using, as you said, in the shipbuilding deck layout. A ship is a kind of a factory, a floating factory with different levels, and each deck can be layouted, simulated before it has been built. I've seen this being using for children playground layouts. Perfect. You can build your equipment because if you see slides and so on, it can be composed in 1,000 different ways. So if you have the right tool sets, the right library components, you can build and lay out whatever you want with this tool. But mainly, initially, this tool has been created to do factory layouts.
Excellent. Yep. All right. Well, with that, so we have a couple of comments that the presentation is awesome. And probably the one that we can take right now is the robot assets that you showed in presentation,
Mm-hmm.
are they just static or they can be manipulated?
Yeah, they can be manipulated, and it can be manipulated by changing the parameters in the dialog. Or if you are more experienced Inventor users, you can even put our logic sliders to this and control it by our logic sliders. So these all these elements that comes out of the box, this one comes out of the box, you can make it your own. You can copy it to your own custom library and make the changes you want to make. So if you have a more flexible need and to use sliders to make it move, throw an logic form over it and it works.
Excellent. All right. Please keep the questions coming. Again, this is less formal meetup for all of us to talk. And while you are thinking about your next questions or like checking the links that we sent, let's move on. And I'd like to give the stage to Steve. And Steve will talk a little bit about the factory solution implementation and where to start or how to get started with it. Steve, the stage is yours.
Thank you. Thanks everybody for joining as well. So Peter kind of touched upon what you can do with factory design. This is kind of an introduction to a course that I worked on with Anton for the last bit and is going to become available today for everybody. And just kind of dive into what we cover in the course and everything like that. So my name is Stephen Porath, or Steve. I have been with Autodesk for 5 years. I am focused primarily on, focused primarily on manufacturing and kind of the automotive accounts within that manufacturing space. I have been doing enterprise support for applications using SQL Server and Microsoft.NET framework and .NET based applications for about 15 plus years. And I started at Autodesk as a vault specialist and have kind of expanded into factory design after getting a chance to see some of the stuff like what Peter just showed, and piqued my interest of what we could accomplish. If I can find my mouse. There we go. So what we cover in this course, or the goals, basically showing you how to set up your own factory design implementation, and kind of the steps involved with that setup. We also touch upon the factory design workflows, such as Inventor to AutoCAD, and everything in the course has been designed to cover Vault as well. Though if you don't have Vault, I did add some recordings to kind of cover those topics as well. And then one of the most important things to me, at least around factory design, is, you know, the asset library. Peter kind of touched upon that and showed what that is. This is meant to kind of show you how you can get that started, get that set up, and, you know, moving forward. Targeted towards anybody who is currently dealing with factory design layouts, but not familiar with the factory design process. And even those that are familiar with the factory design process may find benefit in going through this course to just see the workflow as prescribed. And something I don't really cover in the course, but why I decided to do this. So I got to experience the process firsthand with one of my customers who uses it pretty heavily. And I saw how much it simplified their day-to-day, and identified that that was something that I don't think a lot of our customers have experience with. So I wanted to do what I could to kind of get the message out on how you can get started and kind of jump that first hurdle and get things up and running. I have a accelerator that is kind of targeted in a more webinar focused delivery to cover the workflow and what you can do with factory design. And this is kind of the companion to that with how you can get it set up, while also touching on some of the similar topics. I also have like an IT type background, so not having any mechanical engineering experience is something that is simple enough that somebody who doesn't have that experience can get up and running with it. And then kind of the last one was the ability to avoid costly errors or mistakes or get in front of them way before they would occur. I've gone to factories where, you know, the equipment footprint is measured out by like a cardboard box and whatnot, just to make sure that the space is appropriate for what is going to be installed there, but it doesn't take into account, you know, the 3D environment that factory design utilities allows you to do. It doesn't really give you good collision avoidance and things like that. So it's probably a worst case scenario, but I think a lot of customers probably deal with something along those lines frequently. So. And I'll just dive through the course overview with you guys real quick. And again, this is something that's going to be posted. I don't know if it's available right now, Anton, or not, but it will be, I think, available by end of day.
Yeah, it is available live, and now we'll show a quick demo.
Okay.
After you present. Yeah.
Okay. All right. So, you know, in the course, we touch on the workflow, and the workflow to me is very, very important. And this is the basics of the workflow. It does not necessarily incorporate any of the advanced features. This is meant to get you up and running. So we touch on, you know, the factory design utilities and the interoperability between AutoCAD architecture, Inventor, and I sprinkle Vault throughout. Obviously, there's also a connection to Navisworks. I don't touch on Navisworks in the course at present, but that is an area that I think we're looking at expanding upon in the future. I also touch on the asset library itself, so what that is, how you can kind of get that set up, and everything there. And hopefully, you know, understanding that workflow allows you to simplify your own process and make things easier on you. The products that I cover on there, so I don't know if I would really categorize factory design utilities as a product itself. It is a installation, and it really adds on to the other products. So the ones that I focused on for this course are really the basic ones, things like AutoCAD architecture for laying things out in the factory, Inventor Professional for creating assets and being able to do kind of 3D view of your environment, and then Vault Professional for storing the assets and accessing and storing your layouts. And then what are assets? I think probably most have already come to that answer, but especially looking at Peter's examples, but you know, they're essentially the cornerstone of the factory process. It is your equipment. It is everything that you are typically going to be reusing, though, you know, you can have assets that are not used or reused frequently as well. And, you know, for those that are familiar with Inventor or Inventor experts, I'd say it's similar to a certain degree to the Content Center. Within Inventor, it is a library. And as Peter kind of demonstrated, it's a combination of a 3D model plus a 2D view. It's got things like a thumbnail, and it has additional logic that the Autodesk applications identify as an asset. And, you know, if you're using Inventor, it utilizes the 3D model. If you're using AutoCAD, it uses the 2D drawing. So it's basically an intelligent set of files representing a piece of equipment. And then we touch on the asset lifecycle, which is essentially, you know, kind of creating the assets in Inventor. storing those assets within the Vault environment, and then finally using those assets within AutoCAD architecture. And one of the things that we dive into deeper is what the factory design utilities actually are, what they do, and as I had said previously, they're an add-in for these various products. We touch heavily on the AutoCAD architecture, Inventor Professional, and Vault Professional in the course, but it is basically additional functionality for factory purposes within those applications. AutoCAD architecture, you're basically having the asset browser where you can place assets from. Inventor Professional, you are creating, modifying, publishing assets. And then Vault Professional, you are storing those assets and storing the layouts themselves. So that's kind of a very quick run through what I put together. I do have a quick video that we can share if I can actually figure out where my mouse is. Okay. So this is kind of the recap of the course, but we touch on Inventor to start things off as far as products go. Within Inventor, we go through the asset publication, both from a Inventor part file as well as bringing in things like step file, which is commonly, I think, how most customers are going to start with their assets. We also dive into the files behind the assets and what they look like and what they contain. We also jump into AutoCAD architecture, and there we're primarily focused on the asset browser, how you can place assets, and then also how you can kind of use chaining or asset chaining to piece together assets like a conveyor belt and whatnot. So similar in Peter's example. And then finally, we touch on the Vault environment, how you can set up a Vault to kind of begin playing around with something like this if you do use Vault, and how things look on the Vault side of it. And then also in the Vault topic, kind of the linking and intelligence that Vault gives you, such as look at a layout and see all of the assets used in that layout. You can look at an asset and look at all the assets or all the layouts that utilize that asset. So a lot of hopefully very good and helpful content for those who are not currently doing factory design or are trying to get up and running with factory design. I think that's all for me.
All right. Excellent, Steve. Thank you so much. Great overview of the course. We haven't agreed upon what exactly you'll be showing, and it's a great transition to actually the live demonstration. So let me take the control back and just to show you live what it is and give you the link so you can try it yourself and share with the colleagues who probably need to get started with the solution. All right, so
I did want to make one comment, and maybe you'll answer this in the demonstration. I do definitely welcome any feedback that people have on this. I've done recordings in the past, but they're usually smaller in scale. So if you have constructive criticism, please feel free to send it. And hopefully, most people do find helpful information there as well.
Yeah, and it's just the beginning of the journey again. So from where you are, either you are in completely beginning or somewhere in between, to get to what Peter shown. It's a journey, right? It has a lot of steps, and I will keep posting information about factory design. So it's just the beginning. So far we have several courses. I will post this link in the chat, but this is the preview of the portal. And the good thing, we tried to chunk down the entire learning path into very short 20-minute courses, because we know that in real life, a lot of time of professional engineers is billable, and in general, they're busy professionals. So we try to make sure that you can keep progressing by scheduling 15 to 20 minutes of time per day. But if you do it regularly, you get to where you want to be relatively quickly. And overall, this learning path on Factory is one of many that we recently posted. The section, or the first section that we covered in last virtual meetups was about 2D design, then transition to 3D, and then really advanced mechanical elements and machine design with design accelerators. We have huge curriculum on product simulation with Inventor Nastran, Inventor CAM sustainability, and this is the one that we discussed today, Factory Design Solutions. So before I post the links, let me show you live how it looks like. First of all, this is the page that Peter mentioned. I also posted the link to the chat window. But this is the learning portal that we have for our existing customers. It's free with Autodesk ID. Just use your Autodesk ID to sign in here. So when you sign in, it asks for your regular Autodesk ID, the one that all customers have. And okay, let's see what's going on in my case. Okay, I'm logged in, and if I go to mechanical engineering section, this is where I see this learning path that Steve demonstrated, and we have several courses here, and you can resume it and take any of them, and we'll be posting more and more courses regularly. And also each course has a feedback form. Please let us know how we can improve our curriculum, what you feel about that. And also I wanted to mention about the virtual meetups. There are many ways you can access them, but the easiest one is here, right here in the learning portal. You have community meetups. We have a lot of them. There are recordings over here as well, but the one that we all are part of today is Mechanical Engineering Meetup here, and it has basically two parts. The one we're here today, it's a Mechanical Engineering Meetup, and today's session is on Factory. Next one is simulation. Then we talk about sustainability. So we have a rotation of speakers, and so it's changing. And then we have generative design series, which is also a very interesting one and more specialized when we discuss generative design in manufacturing and generative design in Inventor. Okay, with that, let me go back to questions and also post the link to what we discussed today, so that you can save it and review in your own time. Okay, let's take a look at the questions. And again, all the information is posted in the chat window. Yeah, and we have a question from Thomas that is it available online? Yes, it is available online. I just posted the link in the chat window, and you just use your Autodesk ID to log in, and it's free. All right, so we don't have any questions now, but if you still have any thoughts, please type them in, or feel free. We have a raise hand button. So if you wanna raise your hand, we will unmute your line so you can share your feedback or ask your question. Okay, so it looks like we don't have any questions. Again, please copy the information from the chat window. Let us know how we did. And also the entire information, videos, project files, data sets, everything is available in the e-learning course. So you can not only watch the videos, but actually do the steps that are shown. So you can transform your awareness or knowledge about certain aspects into actual skills. And the only way to do that is to practice. So we give you the some tools to actually practice as well. Please let us know how we did today, because you will have pop-up survey after the webinar. Thanks again to our speakers. Peter, Steve, any closing notes from you guys?
Well, from my side,
thank you for. Oops, sorry. Go ahead, Peter.
So from my side, thank you for being here, listening. And if you didn't discover Factory yet, please do it tomorrow.
Yeah, thanks, Peter. Steve?
Yeah, yes, good point. And yeah, Peter's shown you what you can do with Factory, and hopefully the course can help bridge the gap for those that haven't even started it to getting to that point.
Excellent.
Thank
and
you for having me as well.
Yeah, thank you, Steve. And we'll see everyone next month with our special topic, product simulation in Inventor Nastran. So see you next month. Until then, check out the courses. Thank you so much. Bye.
Bye.
Have a good day. Bye-bye.
Bye.